Hello, class. I hope you enjoyed your weekend, and I hope you're looking forward to the short school week here with having Friday off. Um, this week, we are going to be learning a little bit more about weather and its connection to the water cycle. Um, Namely, we're going to start learning about clouds. So, if you have any questions, I know a few of you have already found this out. The best way to get a hold of me is to email me. And you all should know my email, but my email is tman@peers.k12.mn.us. Feel free to ask me if you have any questions. The directions are always posted into the Google Classroom assignment, so always read those if you're getting confused. So let's get started with notes on humidity. And then I'm going to post another video that shows some notes on different types of clouds. So here are the notes on humidity. And you might be wondering, what is humidity and what does it have to do with what we're learning about? Well, a good question to start with is, well, why do clouds form? Uh, a lot of why the water cycle happens and how clouds form is because of humidity. And humidity is simply the amount of water vapor in the atmosphere. So the air you're breathing right now, you can look through, see any air. That air holds a certain amount of water vapor. That amount of water vapor is its humidity. Okay. There are a couple types of humidity. One type of humidity is called absolute humidity, and this is just a measurement of the amount of water in a space, for example. So, one example of absolute humidity would be saying there is 70 grams of water per cubic meter, something like that. Very technical. This is a measurement of water in the air. This is not a percentage. This is the measurement itself. Okay. The other type of humidity, and the type that we're going to talk about the most today, is relative humidity. This is the amount of water in the air compared to the amount of water the air can hold. Okay, so this is usually a percentage. When you listen to a weather report or you flip on the news and they say the humidity is 70%, that is relative humidity. Okay. Another word I want you to learn is called saturation. Saturation means it's like completely full, can't hold any more. When air is at saturation, it can't hold any more water vapor, right? It's holding as much as it can. It is at saturation. Okay, so remember that word. You'll probably use it other times in your life too, right? When you squeeze a sponge in your sink and it fills up with water, and then you can't fill it up with any more water, that sponge is at saturation. Okay. Okay, so we're going to start off with relative humidity. I really want to dive deep into this because relative humidity is the most useful concept that we're going to learn about for the water cycle in clouds. So, as you can see here, we have three different circles at different temperatures. Now, the picture looks a little complicated, but imagine each of the yellow circles is a different temperature. Okay, so the bigger the yellow circle, the higher the temperature. Relative humidity changes with temperature. So as you can see here, each of the blue circles is exactly the same size, right? The only thing changing is the yellow circles, and that means the temperature. So at 50 degrees, that blue circle completely fills up the yellow circle. It's 100% relative humidity, meaning it's at saturation. It can't hold any more water vapor. Any more water vapor would not be held in the air, if that makes sense. Okay. If you get a little bit warmer, let's say it's at 68 degrees, you still have the same amount of water vapor, right? That blue circle doesn't change, but it only takes up 52% of that yellow circle, right? Warmer air can hold more water vapor. So you have the same amount of water vapor as in the 50 degrees, but the air can hold more. So it's only 52% relative humidity. It can hold 48% more water vapor. That's what it's saying, okay? And if you get even hotter, like this one on the far right at 86 degrees, you still have the same amount of water vapor as you did that you started with at 50 degrees, but it takes up even smaller of what it can hold. So the 86 degrees can hold 72% more water, right? The amount of water vapor doesn't change, just how much the air can hold. And that's your relative humidity, okay? So here are the big takeaways about relative humidity. Warmer air can hold more water vapor. Colder air can hold less water vapor, okay? So you might have the same amount of water vapor in warmer air or colder air, but the colder air can hold less than the warmer air. All the extra water, so if you have more water than the air can hold, so you'd have more than 100% humidity, right? All that extra water in the air becomes liquid, okay? It's not vapor anymore if you have more than it can handle. So if you made it colder than 50 degrees here, all that extra water would become clouds, and if you had enough extra water, it would become precipitation, right? That water vapor becomes liquid water if the air can't hold it. But what happens if you have too much water in the air, right? If there's more water than the air can hold, what happens, you might be asking? Well, that extra water vapor becomes condensation. Some examples of condensation are like dew on the grass in the morning, or if it's up in the air, that condensation sticks to little particles in the air. That becomes clouds, right? That's condensation. So the vapor becomes liquid. You might be wondering, how does this relate to clouds? Well, we're going to start here. During the day, air might warm up. And we talked about density a little bit earlier in the year. As that air warms up, it becomes less dense and it rises up in the air. As the air rises, it expands, okay? So it goes from being pretty dense and warm down at the bottom. As it rises up, it expands and cools off. Like here in this picture, you can see that you have this parcel of air here at 30 degrees Celsius, which is pretty warm. It warms up and starts coming up. The parcel gets bigger here at like 20 degrees Celsius. And as it rises, it expands even more and cools off to 10 degrees, right? So as it goes up in the air, it's expanding and it's cooling off, okay? So that's the big thing. As air rises, it cools off. Now, sometimes the air cools so much as it's going up in the air, it's expanding, it cools off so much, it becomes saturated with water vapor, right? So if you look at the picture here, let's say your air starts at 86 degrees, right? It can comfortably hold this amount of water vapor. It starts to rise and cools off. The water vapor, or the air is starting to lose how much water it can hold. And finally, it reaches saturation, right? It's holding as much water as it can. If it gets colder than it's 50 degrees here, let's say it gets down to 40 degrees, it's not going to be able to hold this much water vapor, okay? So all that extra water vapor becomes liquid, and this means clouds that start sticking to dust and stuff in the air becomes clouds. And if there's enough condensation, it'll become precipitation like rain or hail or something like that. Hey guys, those are the notes on humidity. Thanks for sticking along, and head on to the next part of your lesson. Check your Google Classroom assignment if you don't know what that is.